In this video, I will be discussing the answers to the pre-calculus midterm recap. Beginning with number 1, find the 12th term of the sequence. So the first thing you need to figure out is this an arithmetic or is this a geometric sequence? If you notice, you are multiplying each number by 2 to get to the next number. So in this case, this is geometric. Now, since it is geometric, you are going to use the formula a of 1 times r to the n minus 1 in order to find the specific term. So the first term is 1/8. We know that the ratio is 2 because you're multiplying by 2 every time to get to the next one. And then you're looking for the 12th. So you're going to plug in 12 into 12 minus 1. So your answer is going to be 1/8 times 2 to the 11th power, which is going to give you 256. Again, to figure out the term of going from one to the next, if you take your second term and divide it by your first, that will help you to find the ratio. So in this case, 1/4 divided by 1/8. So in your calculator, if you did 1/4 divided by parentheses 1/8, it will give you your ratio, which is 2. So the second term divided by the first term will always help you to find your ratio as long as it is geometric. Number 2, this is a summation because of the symbol. So the first thing you need to figure out, is this an arithmetic series or is this a geometric series? And this is geometric because you have an exponent that a number is being raised to, so it's automatically geometric. So you are going to use the formula. So for a geometric series, there are two formulas. It is the a to the first times 1 minus r to the n over 1 minus r, or if it is an infinite geometric series, it would be the first term over 1 minus r. Now in this case, it is infinite because of the infinity sign. So we're going to take our first term, and we find the first term by literally plugging in the first term. So if you plug in 0, I'll get 1/2 raised to the 0 power, which is 1. And then on bottom, it is going to be 1 minus the ratio. The ratio is 1/2. 1 minus 1/2 is 1/2. And 1 divided by 1/2 is the number 2. Number 3. This is an arithmetic sequence. They give us the 11th term and they give us the 29th term. So this is where we have to first find the common difference. To do that, we're actually going to use something that's very similar to the slope formula. We are going to take 78 minus 24 on top, and on bottom, we're going to take what the terms were. It was the 29th term, and we're subtracting the 11th term. 78 minus 24 is 54, and this gives you 18, and this gives you 3. This represents the common difference. Now we need to find the first term. So we are going to use the formula, the first term plus the difference times n minus 1 in order to actually figure out the first term. I know that the difference is 3, and I also know that if I plug in 11 for my term, I know my 11th term will equal 24. So I know on the 11th term that is going to equal 24. So I can use that in order to figure out my first term. I easily could have used the 29th and 78 as well. It will still give me the same answer. So when I do that, I'm going to get 24 equals my first term plus 30. 11 minus 1 is 10. 3 times 10 is 30. So I subtract and I'll get -6 for my first term. So I found my common difference. I found my first term. Now I'm going to find the formula. Well, the formula is my first term plus my common difference times n minus 1. So just to clean this up, it would be 3n minus 3. And so it will be 3n minus 9 as my final answer. Next, an auditorium has a sold-out show this coming weekend. There's 15 seats in the first row, 19, 23, and so forth. How many tickets do they sell if there are 43 rows? So what they're wanting to know is how many seats are in the entire auditorium because they sold out the show. So they've sold all the seats, the tickets for the seats. So what we're going to do is, one, I know this is arithmetic. Why? Because they're adding the same number to each row. 15, 19, 23 means they're adding 4 seats to the previous row. If you add 4 to each term, you will get the next row. So I know this is arithmetic. Now I'm wanting to know the total amount of seats in the entire auditorium. So I am looking for the arithmetic series. If you add up all the terms together from 1 to 43, why 43? Because there's 43 rows. It will give me the total amount. The arithmetic series is n over 2 times the first row plus the last row. So we know that there's 43 rows, and we know that there's 15 seats in the first row. We do not know how many seats are in the last row. So what we do is we come over here to the side, and we're going to have to figure it out. We want to know in the last row, in the 43rd row, we want to know how many seats that is. So we're going to use the formula, the first number, which we know is 15, plus the common difference, which we know is 4, because you add 4 each time, times n minus 1. And we know n, it's 43. We know how many rows there are. So if you were to find this answer out, you will get 183. So I know that there's 183 seats in the last row. There was 15 seats in the first row. There's a total number of 43 rows. And now, plugging that in, we will get the answer 4,257 total seats, which means they sold 4,257 total tickets. From a class of 15 students, a president, vice president, secretary, and treasurer was chosen. So we have 15 students, P4. It's P because we are very specific about the titles. A president, vice president, secretary, and treasurer. It actually matters specifically who is chosen where. So we would use a P. Then a committee of 3 people was formed. Well, if you've already chosen 4 people for the different class officers, that means there's only 11 people left and you're choosing 3. C in this case represents a combination because it doesn't matter if you're chosen first or third, it's the fact that you are still on the committee. So if you were to type this entire thing in the calculator, make sure you put parentheses around each one. You should get 5,405,400 different ways that you could choose these students. A survey of high school students find the following things. I am going to draw a Venn diagram in order to help me to solve this problem. We know that there's people in sports, we know there's people in AP courses, and then anyone on the outside is in neither. Now we know that 10% of people are involved in both, so I'm going to go ahead and put 0.10 in there. Now if 42 students were involved in sports, but 10% of those are also in AP, that means 0.32 were only in sports and not in AP. Again, 42 students are in sports, but 10% of those is being combined as well with AP. There is being joined together. So therefore, if you subtract, you will get the 0.32. That would be in sports alone. Now, there's 35% in AP courses, but if 10% also are in sports, that means 25 would be in AP alone. Again, 35% minus 10% would give you 25%. And then to figure out who is not in either, you would add these 3 up and subtract from 100%, and you would get 33% are in neither sports nor AP. What they want to know is the probability the student takes an AP course given that they're an athlete. This right here tells you that you're going to use the probability of A and B all over the probability of B, or the probability of A. It doesn't really matter. So basically, you want to know the probability of both divided by the probability that they're an athlete. So the probability of both is 10%. The probability of an athlete, sports athlete, is 42%. Yes, you use 42%, don't use the 32%. You're looking for the people who are an athlete. There are 42% who are athletes, so you'd use the 0.42. So if you were to put this in the calculator, you would get 0.238, or you could say 23.8% is the probability that a student takes an AP course given that they are an athlete. Next, you are actually going to use a tree diagram in this case. So if it rains tomorrow, the probability that John will practice the piano would be 75%. So if I was to, first, it is either going to rain or it is not going to rain. And then if it's going to rain, he may practice or he may not practice. But if it doesn't rain, he still has a chance of practicing or not practicing. So let's figure out, we know if it rains tomorrow, so we're up here with the rain, if it rains tomorrow, then there is a 0.75% chance that he will practice. So there's a 0.75 that he will practice. That's if it rains. If it does not rain, so now we're down here with not, if it does not rain, there's only a 0.4% chance that 0.4 chance that he will practice. Suppose that the chance of rain is 50%. Okay, so if it's a 50% chance of rain, that means it is not, it's a 50% chance of it not raining, because these have to add up to 100%. If there's a 0.75% chance that he will practice, that means there's a 25% chance that he won't, because again, they have to add up to 100%. And if there's a 0.4 that he'll practice, then there's a 0.6 that he will not. Now, they're wanting to know, what is the probability that he will practice? Well, there's two ways that he'll practice. He could practice if it rains. That's one way to practice. But another way to practice is if it doesn't rain, he could still practice. So these are the two paths that he could practice. So what you're going to do to find out the probability here is you're going to multiply the 0.5 times the 0.75, and you will get 0.375 chance. But in this case, 0.5 times 0.4 is going to give you a 0.2 chance that he will practice. So he could practice this way, he could practice this way. Add these together to get your final answer. So your answer would be 0.575, or you could say it's 57.5% chance that he will practice his piano lesson tomorrow. Number 8, I'm going to do another Venn diagram. So you have A probability, you have B probability. The probability of both of them is a 0.2. The probability A is 0.7, but if I have already used 0.2 in the middle, that means 0.5 is going to be left in A alone. And then probability for B is 0.4, but again, if 0.2 is already used, that means there's only another 0.2 chance of it being B alone. And then the probability of neither is you add these together and subtract from 100%, and you will get 0.1. The probability that A occurs but B does not is basically the probability of A, but not where they're included. So the answer is going to be just 0.5, which is basically 0.7 minus where they're both. The probability of neither occurring is going to be this number over here, which is 0.1. And then what's the probability that B occurred given that A occurred? This is where you do the probability of A and B, probability of both, divided by the probability that A occurred. So the probability of both is 0.2. The probability of A, look at your original probability of A. Don't look at the 0.5. That's A alone. I need A total. So the probability of A is going to be 0.7. So 0.2 divided by 0.7 is going to be 0.2857, or you could say it would be 28.6% that B occurs given that A occurs. Okay, chapter 7 and 8. An investor deposited some money at 1.5% annual interest and then two equal but larger amounts at 2.2% and 2.4%. So there's three variables going on. You have X that is going to be represented at 1.5%. You have Y that represents the 2.2% interest, and then you have the Z that represents the 2.4% interest. But they said something that is very interesting. The two equal, the 2.2 and 2.4, they are equal to each other. So off to the side, I need to remember that Y and Z are actually equal to each other. Now I'm going to write the equations. I know that if you invest all three types of amounts, you're investing $25,000 worth. So I know that X plus Y plus Z is going to equal $25,000. I also know that the amount interest earned is 535. So 0.015x, don't forget to change it to a decimal, plus 0.022y plus 0.024z is going to be 535. But here's the problem. Those are two equations, but we have three variables. But again, off to the side, remember how we said that y equals z? So what I'm going to do is I'm going to rewrite this equation, and I'm going to replace z with y. So x plus y is going to equal $25,000, and y plus y is 2y. So I'm actually going to rewrite that as 2y. Now, I also know we talked about that y and again z are the same amount. So it'd be 0.015x plus 0.022y plus 0.024y, since they do equal each other, equals 535. And since you have a y and a y, I can go ahead and combine these two amounts together, which will give me 0.046y if I was to add the 0.022 and 0.024. So I now have two equations with two variables that I can be able to plug into my matrix. So I'm going to pull up my matrix. So I know I'm going to edit a matrix. It is a 2 by 3. And it's going to be 1, 2, 25,000. And then 0.015, 0.046, and 535. So what I do is quit, go back into my matrix. I'm looking for the RREF, and then I need to tell it which matrix to use. We edited the first matrix, so just hit enter, and the X value, the 1.5%, represents, that's where, so they invested $5,000 at the X value, and they invested $10,000 in the Y and the Z value. So X represents them investing $5,000, and then the Y and the Z represents them investing $10,000 each into both of those equal accounts. Number 10, we cannot use the matrix because we have exponents. So what I'm going to do is I'm going to solve the bottom equation, and then I am going to substitute this in for x. So it will be x squared minus y squared equals 39. And then x represents y plus 3. and now I need to FOIL. So y plus 3 squared will give me y squared plus 6y plus 9 minus the y squared equals 39. Y squared and negative y squared cancel, leaving me 6y plus 9 equals 39. Subtract 9 and you'll get 30, and then divide by 6 and you get 5. So if we know that y is 5, we can plug it back in. And so x will represent 8. So to write this as a coordinate point, it would be the coordinate point 8, 5, which means if you were to graph these two equations, they would intersect at the point 8, 5. Now for number 11, again, we're actually going to use the matrix. So bring the calculator back up. We are going to go into matrix, and I'm going to edit the first one. It doesn't matter which one, but it is 3 by 4. So you get 5, 3, negative 1, 5, 3, negative 2, 4, 13, 3, 5, and 22. So the first thing you do is quit, then go back into matrix. We are going to look for the RREF and then choose the matrix we used, which I still used matrix A, hit enter, and then that represents your numbers. So the X, Y, and Z value represent 1, 1, and 3. And you need to write it as a coordinate point, so that would be your answer. Number 12. There are two ways to be able to solve this. One way is I can add 3 to both sides. Add x to both sides, and then I can substitute this into y. So where you would have y here, so it'd be x, y plus 2 equals 0. But instead of y, I'm actually going to put what it represents, x plus 3. So in order to solve this, I would distribute. I would get x squared plus 3x plus 2 equals 0. This factors into x plus 2, x plus 1, and then to solve it, x would equal a negative 2, or x would equal a negative 1. Now I need to plug it back in. If x is negative 2, then I'm going to plug it back into here. I'll get y equals a negative 2 plus 3, so therefore y would equal 1. If x is negative 1, then I would get a negative 1 plus 3, which would give me y equals 2. So the coordinate points that I would get is if x is negative 2, y would be 1. And then also if x is negative 1, y would be 2. And these are your coordinate points. And again, if you were to graph these two equations, they would intersect at 2 different points. In this one, what you will do is you're going to take the different matrices and you're going to just put them into the calculator in order to figure out the answer. And so if you were to edit a matrix C and a matrix B, make sure C goes first to B, and you should get 113, 28, 10, 44, 81, negative 41, 84, 98, and negative 42. Now, if you notice, 13 and 16 are opposite. C times B and B times C should not be the same thing. You cannot switch places when you're multiplying with matrices. So number 16 is going to be 71, 28, 181 if you were to make the B go first and then the C. Now number 14 I am going to show you because of something that happens. So we are looking for the inverse of matrix A. So I first need to put in matrix A. So I'm going to edit a matrix. I'm just going to use matrix A. It is a 2 by 2. And I would get 4, -2, 1, 3. Now I'm going to quit. Now I am wanting the inverse. So I'm going to go in and get my matrix A that I just edited, and I'm going to hit the x to the -1 because I want the inverse. When you do that, you're going to get a bunch of kind of weird numbers. Here's what you do. Hit math, enter, enter, and it changes it back to a fraction. And I would like the fraction answer of it. So therefore, your answer should be 3/14, 1/7, -1/14, and 2/7. Number 15, this represents the determinant. And so you're going to edit matrix matrix E. So I'm going to go into matrix. I'm just going to edit matrix A again. It is a 3 by 3. And it is 7, -14, 3, 2, -1, 3, 0, 1, 9. 9. Quit. Go back into matrix. I want the determinant. Absolute values mean the determinant of the matrix. And I edited the first matrix again. So hit enter, enter, and 174 is going to be your answer. Now, number 17, the area with the triangle with the vertices is going to be plus or minus. Just make sure it's always a positive. The determinant of the matrix. Now the matrix is going to be 0, -2, -1, 4, and 3, 5, and then you have ones as your last column. So you're going to plug in. I'm going to edit my first matrix again. So I'll have a 3 by 3. So I'll have 0, -2, 1, -1, 4, 1, 3, 5, 1. Quit. So I'm going to do 1/2. So I'm just going to do the 0.5. And then I want to do the determinant. So go to determinant and then choose the matrix that you had edited. Hit enter and you get a -12.5. So all you need to do is just change it to a positive 12.5 as your answer. If your answer comes out negative, just make it positive. If it came out positive, then obviously keep it positive. Chapter 2, write the following quadratic functions in vertex form. So number 18, in order to do the vertex form, we're going to do the -b over 2a. So -12 over 2 times a is going to give me a -3. That is my x value of the vertex. So what we're going to do is plug -3 back in. So it'll be 2 times -3 squared plus 12 times -3 minus 3. That will give me 18 minus 36 minus 3, which will give me a -21. So the vertex form is y equals a times x minus 8 squared plus k. Now, the a in this form is the exact same a as in this form. So therefore, we are going to bring the 2 down into our new form, and there will be x minus a -3, which becomes a positive, because a -3 and a negative give me a +3, and then a -21 for our answer. For number 19, we're going to do the same thing. -b over 2a. So it'll give you -b over 2 times a, which is going to give us a +2 in this case. And then to plug it back in, we'll have 2 squared minus 4 times 2 plus 10, which would give me 4 minus 8 plus 10, which would give me a +6. Now, the a is 1, just like in the original, so we're not going to put a 1 in front. We'll just keep it as a parentheses x minus the x value squared, and then plus the x value plus the y value. Now in this case, we are needing to write the equation. Now it does not say in which case, but I'm going to go ahead and tell you, I would like it in the vertex form at the moment. So we know we have a vertex, which is the point 3, -1. And we also need to choose another point to help us find if if it's compressed or if it's stretched. So I also noticed that you have the point 4, 0 that it goes through. This again is our vertex. So we want to know if that's our vertex, then we know it's going to be y equals a, x minus the x value of our vertex plus the y value. Now we need to check to see if a is 1 or if it actually got stretched or shrunk or compressed, I guess. So we're going to plug 4 and 0 into our x and y. So if I plug 4 into my x and I plug y into my y, I'll get a times 4 minus 3, which is 1, and then minus 1. A times 1 is just a, and then minus 1. To solve for a, I just add 1 to both sides, and a equals 1. So therefore, it was not compressed or stretched because it's a 1-to-1. So therefore, our final answer is going to be y equals x minus 3 squared, and then minus 1. Now, for number 21, for A and B, we are going to do the same thing. I know that my vertex is -1, -2, so it's going to be y equals a times x plus 1, because a -1 and the minus, I'll write it down here, ax minus h squared plus k. So -1 and a negative give me a +1, and then the -2 goes out here. Now, we have another point, which is 0, -1. So if I plug 0 in for x, and I plug -1 in for y, I will get -1 equals a times 0 plus 1 is 1 minus 2. A times 1 is just a, and then I add 2 to both sides, and when I add 2, I will get a 1. So therefore, I know that a is 1. So we don't have to actually put it now. For part B, we are going to have y equals a times x. Now in this case, the vertex is 0, so x minus 0 squared, and then minus 2. Now x minus 0 is just going to be x squared minus 2. Now I cannot tell. I think this point right here, which is 1, -1, is also on the graph. So I'm going to plug a 1 in for x and a -1 in for y. So I'll get -1 equals a times 1 minus 2. So I'll get -1 equals a minus 2. So when I add 2 to both sides, I will still get a to be 1. And so therefore, since a is 1, I can automatically just get rid of it and say that this is my final answer. So we're going to find the zeros of these graphs, and then we're going to graph these functions. So first, let's find the zeros. I can factor out an x first, and I'll be left with x squared minus 4x plus 4. And so this factors into x minus 2 times x minus 2. So when I find the zeros, I know that x equals 0 from this x, and then x is going to equal 2 from this one, and it's going to equal 2 from this one, which means there was a multiplicity of 2. So we know it crosses at 0 and we crosses at 2. Next thing you look at is your highest exponent. It is a 3, which means it's going to go from down here to up there. So we're going to go through the 0, but there's a multiplicity at the 2, which means it is going to bounce. And that is going to be our final graph of starting from low, going to high, and it bounces at 2. And this next one, x is going to equal 0, but there's a multiplicity there because of the square, and we know that x equals 4. So we are at 0 and we're at 4 this time, you have 2 x's here, you have an x here, which means there were 3 x's to begin with. So again, it's going to go from low to high as the end behavior. It bounces here. So as we go up, we're actually going to bounce at 0, and then we're going to go through the 4 in order to be able to graph our equation. In number 24, I can factor out an x squared, and then this factors into x minus 5 times x plus 4. So we know that x equals 0, but there is a multiplicity because of the square. And then we also know that x equals 5, and we know that x equals a negative 4. So at negative 4, it crosses. At 0, it bounces. And then at 5, it crosses. This is an x to the 4th as the highest exponent. So we know that the end behavior is both going to be going up. So from here, we're actually going to be coming from above. So it's going to go through negative 4. It bounces at 0 because the multiplicity, and then it goes through the 5. Sorry, that's supposed to connect. And that will be our graph. A projectile is fired vertically upward with its height in feet, and this is the function. It is talking about a max height. So there's 2 ways to do this. You can either use your calculator, or you can do the negative b over 2a. So I'm going to do the negative b over 2a. So negative b over 2 times a is going to give me 25. So we know that after 25 seconds is when it's going to reach its max height. Now they want to know, what is the max height? This is where you actually find the y value. So we're going to plug 25 back in. So we'll get negative 16 times 25 squared plus 800 times 25 plus 600. And we will get, I believe, 10,600. So after 25 seconds, it is going to reach a max height of 10,600 feet. Now this, after how many seconds will it hit the ground? So if we were to graph this, it's going to be going up, and then eventually it's going to be going back down. Obviously, the top up here is where we found our max height. They want to now know, when is it going to hit the ground? So in this case, I'm actually going to use the calculator for this part. So I'm going to go to my y equals, and this is negative 16x squared plus 800x plus 600. And if I graph this, I don't see it. I see where it goes up, but I cannot see where it lands. So I need to go farther out on my, I need to go farther out on my x. I can see where it gets launched, basically, on the y-axis, but I need to go further on my x. So I am going to make my x values bigger. So let's try 100. Oh, it worked. Okay, this is where the rocket is going to land again. So we are going to hit second, trace. I want to know my 0, where it's going to hit ground 0. So I'm choosing my 0, hit enter. Left bound. I need to get, okay, so there's the left side. So I'm going to hit enter. The right side, hit enter, and the 0 is at 50.74. So at 50.74 seconds, it is going to hit the ground. Now, in case you do not want to do this using the calculator, the other way to do it is use the quadratic formula to find your 0. And you want the positive number of the quadratic formula. But basically what you want to know is that 0 of where it's going to actually hit the ground. Next, find a polynomial. Well, if we know that x equals 0, then we have x equals 0, and at 10 would be x minus 10. So x times x minus 10 is going to give us x squared minus 10x, and that will be our polynomial function. Make sure you FOIL it. In this case, we know that x minus 0, x minus the square root of 5, and x plus the square root of 5. We know that x minus 0 is just x, and then we're going to FOIL. X times x is x squared. X times the square root of 5 is the square root of 5x. Negative x times the square root of 5. And then square root of 5 times square root of 5 is the square root of 25. And the square root of 25 is the number 5. And then we also notice that these two middle cancel, leaving me the x in the front and then x squared minus 5. So our final answer is going to be x cubed minus 5x. Here we are going to have to use long division because of that exponent. So we'll have x squared plus 1 all over x cubed. That should be an x cubed. You need a placeholder. Minus 9. X squared times what gives me x cubed? X. So x times 1 is x. X times x squared is x cubed. Now you need to change the signs because you're subtracting. So I'm going to make that a minus, and I'm also going to make that a minus. That cancels. 0x squared is just 0. And 0x minus x is a negative x. And then I'm going to bring down my minus 9. I cannot do x squared goes into x because that has a larger exponent, and so you're done. The final answer is going to be x squared plus 1. Nope, just kidding. No, it's not. Our final answer is the top number, which is x, and then the remainder over what you had divided by. And that would be our final answer. Now here I can use synthetic division because this is not an exponent. So I'm going to make what's on the shelf to be 2 because you basically set this equal to 0. So you'll get 2. 9, negative 18, these two are switched. Be really careful. The negative 18 goes first. Negative 16 and 32. So when I use synthetic division, I'll bring down my 9, 18, 0, 0, negative 16, negative 32, and another 0 for the remainder. So my answer when I divide by x minus 2 is going to be this result down here, which is 9x squared minus 16. That 0 represents the x, so you do not put it. Now in this case, we are actually need to figure out what should go on the shelf. 2, 3, negative 8, 3. I always love to start with the number 1, so let's actually try it. I bring down the 2, 2, 5, 5, negative 3, and it worked. So we know that 1 is a 0. So I'm going to take what is left, which is 2, 5, and negative 3. And then I could always try a 1 again to see if it works. If I bring down the 2, I will get a 2. I'll get a 7, 7. Nope, that's not going to work. I could try a 2. Bring down the 2. That will give me a 4. That will give me a 9. That's 18. Nope, that will not work. I'm going to try a negative 3 then. Bring down the 2. That'll give me negative 6, negative 1, positive 3, and it actually worked. So we know that negative 3 is now a 0. I'm going to take what is left with it just 2x minus 1, set it equal to 0. So I'm going to add 1 and then divide by 2, and I will get 1/2. So 1/2 is my final 0. In this case, got to find the shelf. So 1, negative 9, 27, negative 27. If I try a 1, I'll get 1, 1, -8, -8, 19. That's not going to work. If I try 3, bring down the 1, 3, -6, -18, 9, 27. This worked. So we know that 3 works. So I'm going to take what's left, x squared minus 6x plus 9. I know that this factors. This factors into x minus 3, x minus 3. So I can set them both equal to 0. So I'll get 3 and 3. So actually all of my zeros were 3s. So you could either write 3 3 times, or you could say 3 with a multiplicity of 3. Complex number. So in the complex number, you're going to have a real part and an imaginary part. So I know my answer is going to be 1 plus something with an I, because the square root of negative is I. Now, the square root of 8 can be broken down into the square root of 4 times the square root of 2. The square root of 4 is 2, and then I have the square root of 2 left, and that would be my answer. I squared, I know, is actually the number -1. So I'll get -1 plus, now the square root of a negative is going to give me an I. So I know I is going to be this answer. I cannot take the square root of 6, and I also cannot reduce it. So that would actually be my answer. Okay, in this case, please do not say that -6 times -2 is a positive 12 and then reduce. You cannot do that. What you need to do is say that this is the square root of 6 times I, and this is the square root of 2 times I. I times I is going to give me I squared, and then 6 times 2 will give me 12. I squared is the number -1, and the square root of 12 can be broken down into the square root of 4 times the square root of 3. So the square root of 4 is 2, so -1 times 2 is -2, and then you're left with the square root of 3. Again, do not multiply a negative times a negative that's underneath the square root. You cannot do that. You need to bring it out as an I first, and then find your answer. In this case, you're going to distribute. 6i times 4 is 24i, and then 6 times 3 is 18i squared. Now, don't forget, I squared is the number -1. So -18 times a -1 is going to give me a positive 18, and then I have 24i as my answer. Quadratic formula, so you will have A is 9, B is -6, C is 37. So I'll get negative B plus or minus the square root of B squared, that's not B, of B squared minus 4AC all over 2A. Negative and a negative give me a positive 6. 6 squared minus 4 times 9 times 37 is going to give me 12. Let's see, where is it? Will give me 1296 all over 18. Now, that should be a negative 1296. Now, negative 1296, you can actually take the square root of. It is a 36i. It's an I because it's the square root of a negative. And then you can divide everything by 6. If you notice, they have a 6 in common. 6 divided by 6 is 1. 36 divided by 6 is 6. And 18 divided by 6 is 3. So that should be your final answer. Okay, in this case, A is 5, B is 0 because there is no number in the middle, and C is 3. So we'll get plus or negative B plus or minus the square root of B squared minus 4AC all over 2A. So 0 just goes away. So we're left with 4 times 5 is 20 times 3 is a negative 60 all over 10. 60, well, first you know that there's going to be an I. And then 60 can be represented as 4 times 15. The square root of 4 is 2. And then 2 over 10 is going to give me square root of 15i over 5. Now to find the zeros, we do not know what to put in the shelf. We know there's not an x to the 4th, so put a placeholder. The number I always love to start out with is a 1. So let's try it. 1, 1, just kidding, that's not a 0. 1, 1, 2, 2, 4, 4, negative 8, 0. Yay, it worked. So we know that x equals 1 works. Well, if it worked once, might as well try it again. So 1, 1, 2, 4, negative 8. Let's try it again. So 1, 1, 2, 2, 4, 4, 8, 8, and it worked. So we know that it worked twice. Now these are all positive numbers on the end. So I know a positive cannot work anymore. We need to go to a negative. So 1, 2, 4, 8. We could go with a negative 1. So if I bring down a 1, negative 1, 1, negative 1, 3. Yeah, that's not going to work. So let's try a negative 2. If I bring down the 1, negative 2, 0, 0, 4, negative 8. And it worked. So I know that negative 2 worked. Now we get down to x squared plus 4 out in this case. At this point, I'm going to have to set it equal to 0 and solve it differently. So I'm going to subtract 4 from both sides. And then to solve, I'm going to take the square root. And I will get x equals plus or minus. Don't forget the plus or minus. When you take the square root of both sides, it's plus or minus. The square root of 4 is 2. And the negative is going to bring the answer to a 2i. So our answers are going to be 2i and a negative 2i. And that's all 5 of my answers. 1, 1, negative 2, 2i, and negative 2i. Next, we have x to the 4th minus 81. You can either use synthetic division, or I noticed that you actually can factor it. So you'll get x squared minus 9 and x squared plus 9. So when I solve them, I would add 9 to both sides, take the square root, and you should get plus or minus 3. So there's 2 of your answers. In this case, you would subtract 9. That becomes a negative 9. So when you take the square root, you will get 3i. So there's all 4 of my answers. 3, negative 3, 3i, and negative 3i. This last one, we have 1, negative 2, negative 11, and 52. Now, I'm not going to try the number 1 because I'm pretty sure with 52 being so much larger than these other numbers that it's not going to work. So I'm going to have to try something with like a 2, a 4, or a 13, or a 52, because those are the factors that go into 52. So I'm going to try a 4. For 4, that's not negative. It should be positive. Should give me 2. That gives me 8, negative 3. That's not going to give me 52. So that's not going to work. I wonder if a negative 4 will work. Bring down the 1. That gives me a negative 4. That gives me a negative 6. This gives me something bigger. Okay, 24. This gives me 13 and negative 52. That worked. So we know that negative 4 is one of my solutions. In this case, I have x squared minus 6x plus 13 left. This is not factorable at all, so you will have to use the quadratic formula. So I will get a negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'll get a positive 6 plus or minus the square root of 36 minus 52 all over 2, which will give me 6 plus or minus the square root of a negative 16 all over 2. The square root of a negative is I. The square root of 16 is 4. And then I notice that my numbers are all even, so I can divide by 2. So my zeros will be 3 plus or minus 2i divided by 1, or just 3 plus or minus 2i. Okay, polynomial function with a given zeros. Well, if 5i is a 0, that means a negative 5i was a 0. So we know that x minus 1 is a factor, x minus 5i is a factor, and x plus 5i is a factor. I'm going to go ahead and FOIL the ones with the i's first, and I'll get x squared plus 5ix minus 5ix minus 25i squared. Now, I know that the two middle cancel. If they don't, there's something wrong. They're supposed to cancel. I'm left with x minus 1 times x squared plus 25. Why is that a plus? Because this I squared and this negative make it a positive 25. And now I can FOIL, and I'll get x cubed minus x squared plus 25x minus 25 as my answer. Okay, if I is a 0, then negative I is a 0. If 6i is a 0, then negative 6i is a 0. So we are going to have x minus I, x plus I. Then we'll have x minus 6i, x plus 6i. FOIL these two first, so I will get x squared plus xi minus xi, and then minus I squared. Here, these two FOILed will give me x squared plus 6ix minus 6ix, and a minus 36i squared. Now, the two middle terms should cancel. If they don't, we did something wrong. So whenever that happens, we are left with x squared plus 1. Why? Because the I squared and the negative are going to turn to a positive 1. I squared is negative 1, but negative 1 times a negative gives you a positive 1. And then here, you're left with, And then here, you're left with x squared plus 36. Why? Because you have an I squared and a negative. I squared is negative 1, but that negative and the negative change it to a plus 36. And now you can FOIL. You'll get x to the 4th plus 36x squared plus another x squared plus 36. So your final answer is x to the 4th plus 37x squared plus 36. Whew. Next. Okay, we know that 5i is a 0. That means we know that negative 5i was a 0. So therefore, together, you would have x minus 5i and x plus 5i. So therefore, that would give you x squared plus 25 if you were to FOIL this. Because 5i times 5i is a negative 25i squared, but the I squared and the negative give you a positive. This is what we are going to factor into our polynomial to find out what we would have left. So, x squared times what gives me a 2x cubed, and the answer is going to be 2x. So 2x times 25 is a 50x, and then 2x times x squared is a 2x cubed. Now, we are subtracting, so I got to make that a negative and make that a negative. They cancel nicely. So I'm going to bring down the 3x squared and bring down the 75. And now I'm going to do it again. X squared times what gives me a 3x squared? And the answer is 3, because x squared and x squared, they're the same exponent. So you get 3. 3 times 25 is 75. And then 3 times x squared is 3x squared. But we are subtracting, so I got to change that to a minus and then change that to a minus. They cancel, leaving me 0. So therefore, 2x plus 3 was my other factor. Set it equal to 0. I'll get 2x equals negative 3. So x equals negative 3/2 was my last 0. So 5i was a 0, negative 5i was a 0, and then negative 3/2 was your last 0. Okay, write this as a log function. So this would be log of 4 raised to the negative 2 is going to give me 1/16. Right, as exponent, it would be 5 raised to the y equals 20x. Find the value. This is the same thing as saying log base 7 of 7 to the negative 1. Log 7 of 7 cancels each other, leaving you the exponent of negative 1. This one would be 9 raised to the negative 1/2 equals y. And the square 1/2, well, negative means you're going to put it on bottom. And 9 to the 1/2 is the same thing as saying the square root of 9. So your answer is going to be 1/3. Log 7 of 7 to the third is the same thing as taking your exponent and then putting it down front. And log 7 of 7 is 1. So your answer is 3 times 1, which is 3. In this case, you're saying 3 to the what number is going to give me 1, and the answer is 0. Expand. If you're multiplying, then you would add log, so you would have the log of x squared plus the log of y. And then division means subtraction, but there's multiple things in the denominator, so you need to put a parentheses. And it would be log of 5 plus log of w to the third. Now, this is actually not quite your final answer because we have some exponents. So the 2 actually needs to be put down front, and this 3 also needs to be put in front of the log, and that would be your final answer. Any exponents need to be put down front. Write as one log. Well, this 1/2 is the same thing as a square root, so I can write this as log times, log x times y to the third, and then all of that raised to the 1/2. And then minus means division of 5w. Now, 1/2 is the same thing as saying the square root. So that would be my final answer. Okay, to solve, this log has a base of 10, so we can rewrite this as 10 raised to the second power is going to equal 3x minus 2. So I will get 100 equals 3x minus 2. So 102 equals 3x. So therefore, x is going to give me 34. In this case, anytime you have a log equal to a log, you can cancel them, and you'll get x plus 4 equals 3x. So subtract x, and you'll get 2x. Divide by 2, and x equals 2. In this case, you would have 4 raised to the x. 16 is the same thing as saying 4 squared. And now I can distribute. Since you have bases that are the same now, they will cancel each other, leaving me the exponent. So I'll have the exponent of x on the left, and on the right, well, I'll have 2 times 2x minus 3. So x equals 4x minus 6. Subtract 4x, I get negative 3x equals negative 6, and so x equals a positive 2. Now, in this case, you cannot do this. I mean, there is no common base. So I'm going to rewrite this as a log. Log base 3 to the 1 minus x equals 2. Now, in your calculator, you can find the answer of log base 3 of 2, and you'll get 0.631 equals 1 minus x. So I'm going to subtract 1 from both sides. I'll get a negative 0.0369. Nope, no, I don't. 0.369 equals negative x. So just divide by negative 1. And so x is going to give you 0.369. Now, you cannot, you got to combine the logs into one log before you do anything else. So this is the same thing as saying log base 5 of x divided by x minus 4 equals 1. And now I can write this more as an exponential function to get rid of the log. So this is 5 raised to the 1 equals x divided by x minus 4. And now I can cross multiply. If I make everything a fraction, I can cross multiply, and I will get 5 times x minus 4 equals x times 1. So I'll get 5x minus 20. So I'll get negative 20 equals negative 4x, and so x equals 5. In this case, I cannot do this because you have more than one log on the right hand side. You got to combine it into one log first. So I'm going to move this 2 back and make this a log x squared. And then this would be a log of 2 divided by, no, not divided. This would be a log of 2 times 3x minus 4. Now that the logs, now that you have one log on one side and one log on the other side, now you may cancel them, leaving you x squared equals 6x minus 8. Now this is basically just a quadratic, so make it equal to 0. So I'm going to put everything on one side. So I'm going to subtract 6x, and I'm going to add 8 so that's equal to 0. And then this would be x minus 4, x minus 2, I believe. And so x will equal 4 as an answer, and x will equal 2 as an answer. The half-life of cesium-137 is 30 years. Suppose you have a 10-gram sample. How much will remain after 80 years? We are going to use the formula T over D. Okay, we know that we're starting out with 10 grams. And we know that the half-life is 30 years. So we know that every 30 years, it's going to take half. So I know that 30 is going to be my variable for D. And now I want to know after 80 years, so I'm going to plug in 80 to find your answer. So type this into the calculator, and you will get 1.57 grams left. Now we want to know how long will only 20% remain. Well, 20% of 10 grams is going to be 2 grams. So we are going to set 2 equal to that. We started with 10 grams. We want to know when we get 2 grams left. We know that every 30 years, half is gone. We want to know how much time it takes in order for this. So to solve for this, we're going to divide by 10. So 2 divided by 10 is going to be 1/5 or 0.2, which is where we started with, basically 0.2. And that's going to give me 0.5 raised to the t over 30. So I need to rewrite this as a log. So it's going to be log of 0.5 raised to the t over 30 equals 0.2. So in your calculator, go ahead and find the left-hand side, and you will get 2.3219. And that's going to be equal to your time over 30 years. So multiply by 30. And you will get 69.66 years is how long, after how long 20% will remain.